Hey team, Andre from High Performance Academy here. Welcome to another one of our webinars, and this time we're going to be diving into using a power distribution module to control a windscreen wiper motor. I know on face value that sounds pretty boring, but this is one of the consistent tasks that people struggle with when they are setting up a power distribution module, PDM, PDU, whatever you want to call it. And there are some specific reasons why that's the case. Before we dive into that though, just an update on a few things that have been going on since our last webinar. And I want to start just by promoting our latest giveaway. We'll jump across to my laptop screen, and the giveaway has just gone live. So we've got a full month left to go. So a great opportunity to get your name into the draw now. We've partnered with Daniels Manufacturing Corp, DMC as they're more commonly referred to. And this is the go-to manufacturer of the industry standard tooling for crimping professional motorsport connectors, the likes of the AS Autosport range of connectors, which are so common in professional motorsport wiring harnesses. So this prize package includes also a set of ideal Ergo Elite wire strippers. Those are my favorite. You can see that those are pictured right there. And I mean, it might sound silly. Why do you care about the ergonomics of a wire stripper? I can assure you that you are going to be stripping a lot of wire when you're building a complex harness, and these are much more comfortable than anything else I've used. More importantly though, the functionality of those wire strippers. I know a lot of people seem to be obsessed with using a set of side cutters to remove the insulation from wiring. That is definitely not what we want to be doing. The reason for this is twofold. First of all, it's going to be very easy to end up actually cutting through some of the strands of the conductor underneath. And basically when you do that, the wire is no longer going to be capable of handling or supporting the current that it should be capable of. It also reduces the cross-sectional area of the wire strands, which can affect the integrity of the crimp that we'll be producing. Secondly, very difficult, if not impossible, to get consistent strip length. So the Ergo Elite wire strippers have a set of blades that are designed for the tensile wire that we use in professional wiring. They have a variety of different positions suitable for different gauges of wire depending on what you're working with, and they also have an optional little wire stop, and that's really important for getting that consistent strip length. So we've got those. We are also accompanying that with a DMC crimp tool, and we've got a turret head to go along with that as well. So basically this is going to get you up and running if you want to start building professional level wiring courses. We're also adding in HPA's VIP membership. You'll get access to every single course we currently offer, as well as every course that we ever produce in the future for life. Total price package there over $3,000 US. So if you are interested in lifting your wiring game, this is a great place to get started. That VIP membership, of course, gives you access to our wiring fundamentals, our club level wiring course, and our professional wiring course as well. So you'll know exactly what to do with all of that equipment. So I'll get Scott to drop that link into the comments that you can follow to get your name into the draw. It's absolutely free. We will ship these to your door regardless where you are in the world. Now I've just come off a weekend of racing up in the North Island of New Zealand in a little EG Civic, and I just wanted to talk very briefly about a tool that we were using on the weekend to help with our pit stops. And we've also purchased a couple of these to use on our SR86 when we get into our endurance racing season down here in the South Island. And that's this thing here. It's called a Speedsocket. This is not a sponsored promotion either, by the way. We actually paid for these full value. The only reason I'm talking about these is because they are quite unique, and I'm really impressed with how they work. So obviously, if you are not in a position where you've got a budget for center lock wheels, then changing wheels in a pit stop and trying to do it quickly can be pretty time consuming. It's also very easy to end up misplacing the wheel nuts. And how this works in a nutshell is it's spring loaded. As you can see, the socket is very long, and it comes with special wheel nuts as well, lug nuts. And basically when you take the wheel off, the wheel nut actually goes up inside that socket. It is a little bit tight for me to do this by hand, but I can assure you that's exactly what happens. There we go. And basically, as you take off the wheel nut, you take off the first one, then you don't need to hold the wheel nut. It gets captive inside of the speed socket. Then you simply put it on the next one, and 4 or 5 stud wheels, you can fit all of those nuts up inside the socket. Because it's spring loaded, the next step is when you go to put the new wheel on, you just feed this onto the stud, use your rattle gun, and away you go. The really cool part about it, and I'm not entirely sure how this works, I think there's some kind of magic going on, but the socket is actually, the wheel nut I should say, is not actually held tight by the outside of the socket. There's a set of little floating balls inside here that support the wheel nut, and it's probably a little bit hard to show you, but let's just get this under the overhead here. Basically, you can move, there's a little bit of axial or movement in the nut. Why that's important is that it means that it is basically impossible to cross thread. So you don't have to slowly start the wheel nut onto the stud, get it a few threads in before you can actually fire the rattle gun. You can go straight for the stud and hit the rattle gun straight away. So it's really, really quick and easy to use. And I did take a little video when we were racing on the weekend, which I just want to show you. This is Brandon just practicing our pit stop strategy. So I'll just show you that there. This is a little EG Civic that I was racing. Get the wheel on, and as you can see, just hit it with the rattle gun and away you go. So obviously not quite as quick as having a center lock hub, but I can guarantee you much cheaper. So if any of you are maybe in a situation where you need to do speedy pit stops, this is a great way of getting that done. The next little product that I wanted to talk about, this is going to be a bit of a product show and tell, I guess, ranging across a few items that we've got in the shop at the moment that I've found pretty interesting. If I find them interesting, I suspect probably a few of you out there watching also will. So the next one is this little connector here. This is going to be a little bit hard to show you in detail, mainly because it is so small, but we'll get it under the overhead light here. So this is a connector body from TE Connectivity. This is their AS Composite series, and if I can just open that, that's the 2 halves of this connector. Now, I know it's small. This is actually a 6-position connector, so you can actually fit 6 22 gauge wires into this. It is incredibly small and a significant step down in size from the likes of the DTM range of connectors that would probably traditionally be used instead if you are not going to the trouble and expense of using a proper Autosport connector. So obviously there's a range here in terms of size, weight, and also the cost that goes along with these. I'll see if I can quickly just find a comparable DTM connector. I probably don't have one at my fingertips. This will probably do. Just as a bit of a size comparison here, as I mentioned, this one here is a 6-way. So we'll put that side by side with a 3-position DTM connector, and it's pretty apparent just how massive the difference in size is. Now, to use these composite series connectors, there are a few tricks to it though. It comes with the same contacts that we would find in a conventional Autosport connector. You can see we've got the same insertion and removal tools that anyone who has used an Autosport connector would be familiar with. What this means is you do need the correct crimp tool. Typically that's going to be the DMC crimp tool, much like I promoted in our giveaway at the moment. So there's a little bit more cost involved with working with these, but of course they aren't a very cheap connector anyway, so they're not going to necessarily appeal to those building a modified street car or club level. I just wanted to show you that this is another option over and above the DTM connectors that's not going to quite cost you as much as a proper Autosport connector. Other advantages with this connector is, again, it's probably going to be a little bit difficult to show you on our overhead, but we'll see if we can. There is a little lip on each side of the connector body. So these are designed to work with heat molded boots on each end to properly seal them. And I know, yes, you can do the same with a DTM connector, but it's definitely not as clean and tidy. So these are designed from the get-go to work with those heat molded boots. The other thing about it, because it's a composite or thermoplastic body, the part is actually designed to withstand the heat that's required to properly recover those boots down. Anyone who has recovered the boots onto a DTM connector, you'll know that you need to be a little bit careful because it is quite easy to actually damage the connector body. So there you go. Anyway, just another option if you are looking for connectors. As I've said, they definitely aren't cheap, and they're not going to be for everyone. Next up are just a component, or a couple of components that are going into the FJ40 build that I wanted to cover. The first of these is the MoTeC LTCD. So this stands for Lambda to can. The D in this case, of course, is for dual. We've got a 4.3 litre 3UZFE V8, obviously 2 banks of cylinders. We're going to have 1 Lambda sensor per bank. Now, there's nothing particularly new about Lambda to can units from MoTeC. They are also available from a range of different manufacturers. But I just wanted to talk a little bit about why I'm such a big fan of using a can-based Lambda controller. And the alternative, of course, for getting air fuel ratio data into your ECU or dash or logger or whatever is to use a controller that will give out a 0 to 5 volt analog voltage. Now that can work, however there's 2 big downsides. The biggest, in my opinion, is that typically you're going to have a lot of trouble with ground offsets. The sensitivity of the voltage that the ECU sees is going to be very much driven by the ground, how the sensor is grounded. So if there's any ground offset, basically it affects the accuracy of the voltage signal that the wideband controller is sending out versus what the ECU is seeing, because we are then scaling that 0 to 5 volt signal across our air fuel ratio or Lambda scale. This means it's very easy to have a small ground offset create quite a large inaccuracy in the air fuel ratio data we're actually seeing or displaying on our laptop. So obviously that's the last thing we want with a critical input like air fuel ratio. The other aspect though that's just as important is that most of the analog controllers are relatively dumb, and by that I mean that they don't provide any diagnostic information to the ECU. In this way, if the sensor is deemed faulty, the controller will probably end up sending out some garbage value on that 0 to 5 volt analog voltage output. Depending how that's scaled, the ECU will then read something completely incorrect. If you're relying on that for closed loop fuel control, who knows what is going to happen. So these provide a very accurate output because it is sent as a CAN message. The integrity of the data is guaranteed. So whatever this is sending out in terms of air fuel ratio Lambda, we're receiving exactly the same result at the ECU. So that's the first and most important part. But then there's also the ability to send diagnostic information. So this allows the ECU to ignore the Lambda sensor if it is deemed faulty. So these days, this is really the only option I would consider for getting air fuel ratio data into an ECU, except for, of course, a lot of the mainstream ECUs that are coming out now will have a built-in Lambda controller on board where you just wire the sensor straight up to the ECU. Essentially, we're getting exactly the same result. We just don't need to remotely mount it. The nice thing about some of these units is, first of all, it's not going to chew up your pin count on the ECU header plug, so you can free up the header plug to do other tasks, which can be important if you're getting towards saturating what the ECU is capable of. And also, you're a little bit more flexible in where you want to mount the controller. That one is weatherproof. It's completely sealed in epoxy as well. So yeah, just all you need to do is run 12 volts and ground to it, as well as CAN high and CAN low, and your job is done. The next sensor that I want to talk about is this one here from Bosch, and this is for our oil temperature and pressure. Again, there is nothing new about this sensor. Don't think that I'm saying that it's a brand new item. It's just that I do know a lot of people aren't aware that sensors like this exist. We'll get it under our overhead, not that there is a huge amount to see here. So as I mentioned, this is a combined temperature and pressure sensor. I've just got a little adapter here that I'll take off. And for the likes of fuel and oil, this allows us to monitor both the pressure. This runs just under 10 bar, I think, off the top of my head, about 145 PSI. And it is 10 bar, 145 PSI. And also, obviously, yeah, measures the temperature. One of the aspects that is a little bit tricky is the fitting. This is an AN fitting, so this particular unit I purchased came with this nice little adapter that adapts it to a 1/8 NPT, which is what we would more usually find for, usually use I should say, for the likes of the common Honeywell 0 to 150 PSI pressure sensors. Obviously the wiring is going to require two inputs, analog voltage just like normal for our oil or fuel pressure. That's going to also require a sensor 5 volt and a sensor 0 volt. And then the temperature, of course, goes to an analog temperature input on the ECU, which requires an internal or potentially an external pull-up resistor if you're using an analog voltage input. So just going to simplify your plumbing significantly, as well as simplifying your wiring, because you don't need to wire to two separate sensors. So one to keep in mind if you weren't aware of that and you are looking at temperature and pressure on fuel or your oil. Last one, again, nothing new about this, which is the Continental ethanol content flex fuel composition sensor. So I'll just get this again under our overhead here. So this one here, there's a couple of different options with these in terms of the way they are, the barbed inputs that I'm just going to try here to remove. They're short and long, which is just going to be dependent on your application as to which works. I should have probably undone this before we went live, but I didn't. I just wanted to mention two things about these sensors that people may not understand or be aware of. The first is that these sensors use a digital square wave output, and they vary two parameters about that square wave. They vary the frequency in relation to the ethanol content. Stretching my memory here, but I think from memory they go between 50 Hertz for 0% ethanol and 150 Hertz for 100% ethanol. So that's the first thing that ECU or whatever you're using to read it will be decoding, is the frequency of the signal. The other part, and this is the bit that a lot of people probably aren't immediately aware of, is that as well as the frequency, they're also modulating or changing the pulse width, and the pulse width is going to also give the fuel temperature. The way these sensors work is that they require to understand the fuel temperature in order to accurately decode the ethanol content, because that's just the way the sensor works. So as an added bonus though, because it's measuring the fuel temperature, that's then an input that is available to us. You might be thinking, well, why do we actually care about fuel temperature? It's really exactly the same as our air temperature and why we need to monitor that. What we're looking at to achieve a specific air-fuel ratio is we need to understand the mass of air and the mass of fuel. That's what that ratio is. It's a mass ratio, not a volume ratio. Now, the aspect with air and fuel is that as the temperature of either change, so does the density. And basically, most people would understand that hot air is less dense, it contains less oxygen. Same with fuel. As our fuel temperature increases, its density decreases. So if we're injecting a fixed pulse width or a fixed volume of fuel, we're going to end up with a different mass being delivered as the temperature of the fuel varies. Now, admittedly, it's not quite as sensitive to the fuel temperature as the air temperature, but it will affect our air-fuel ratio. So if we've got the ability to monitor and compensate for that, which most modern ECUs do, why not do it? And again, that's two signals on just a single digital input, so it's not very intensive for the ECU to process. The other aspect though, which I was struggling with, is just talking about how we can adapt these into our fuel system. These are little AN adapters from Speedflow, and rather than trying to run hoses on it, as you can see here, basically this just awkwardly, I'll try and put this together. This just connects up over the little barb in our hose, and it is a thread there. There's a little O-ring inside that unit that I just slid on that seals everything, and because the second part that we're just screwing it into now is over that barb, once it's installed, it cannot fall off, can't come loose, and that allows us to really easily adapt to AN fuel lines, which we'll probably be using for our fuel plumbing anyway, and those are available in Dash 6 and Dash 8. So hopefully some little information tidbits there that might be useful to some of you in the future. All right, we'll move on, and if you haven't been spending time on our YouTube channel lately, it's definitely a good time to jump back in, and we'll just head over to my laptop screen. We have been starved of content for the last little while for some very obvious reasons, given that we haven't been able to travel. A few weeks ago, we were able to get over to World Time Attack in Sydney, and we've got a lot of content coming out from that visit. This one was a chat with Shannon from Plasma Man, specifically around what we need to consider for throttle body sizing. And I know a lot of people kind of consider that when it comes to throttle bodies, it's just a case of bigger is better, correct? Well, there is actually a little bit more to understand, and bigger definitely is not always better, and it can come with some pretty big downsides, particularly in terms of airflow control and how that relates to the driver's foot pedal position. So this chat with Shannon is going to be perfect for those of you who maybe are considering an upgrade of throttle body, and yeah, maybe you'll find out that what you'd thought about throttle body sizing isn't entirely based on fact. So go check that out. Give us a thumbs up if you like the video. If you haven't already, make sure you're subscribed, and feel free to ask any questions you've got in the comments. We're pretty active on getting back to anyone who has been asking questions. In terms of our content as well, if you haven't been listening, please make sure you check out our podcast, the HPA Tuned In podcast. I've got new episodes dropping every week. Our latest episode, we talked to Jake from MoTeC Motorsport, and Jake and MoTeC Motorsport specifically make quite a novel controller, which I found really interesting, particularly with the current crop of late model direct injected engines. When it comes to increasing the power level significantly, one of the limiting factors can be the size of the factory direct injectors. And unlike in the port injector world, it's not always that easy to just go and purchase an aftermarket set of larger injectors. They are very specific to the application, so that's not always an option. Another option to solve that problem, however, is adding secondary injectors, which are port injectors. So we can use direct injectors, and then when we run out of fuel with those, we can just start staging in port injectors as well. But controlling that is problematic. So Jake and his company MoTeC produce an aftermarket controller that does exactly that. They are well known in the A90 Supra world as well as across the BMW platform, and their controllers currently on the fastest and quickest A90 Supras down the drag strip. Now that's all well and good. You might be thinking, but how do we program all of that? And it sounds like a bit of a mess if we're reflashing the factory ECU, but then also we're dealing with this aftermarket controller and we're tuning two things at once. Could get a bit messy, and granted it could. What's really unique is that MoTeC are working hand in hand with some of the reflash packages like ECUTech to actually get support for the MoTeC reflex auxiliary injector controller directly from the ECUTech tuning platform, and that's all communicating with the factory CAN bus. So it's pretty trick how that's working. Gives a lot of flexibility in terms of some diagnostic elements as well, which obviously becomes really important if something goes wrong in a very high horsepower application. You can check out HPA Tuned In anywhere you currently listen to podcasts, and we'd love it if you could leave us a review. Only if you like it though. We don't want any bad reviews in there, please. But on a serious note, we're really enjoying the content we are producing out there on that podcast. We've managed to chat with some really interesting people, and I'm sure that if you want to increase your knowledge on the aftermarket performance industry, it is going to be a great resource for you to consume. So that's HPA Tuned In. Right, we will finish up by just a reminder that we've got that giveaway running for our DMC Crimp tools, our ideal Ergo Elite wire stripper and HPA VIP, total value $3,000 US. Remember, again, there is a link in the comments that you can follow to get your name into the draw. 31 days left to run. Please don't miss out. Remember, we will ship the prize package free of charge to your door, regardless where in the world you live. All right, give me a moment here and we'll get started with our webinar. If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.